Hello, welcome to Joe's Classroom. Have you ever wondered how you can work out a Bode plot exercise without having a physical semi-log graph sheet with you? Here is the solution. This video explains how you can use a soft semi-log graph to sketch the Bode plot of the given transfer function. For this, I use the website incompetech.com/graphpaper/logarithmic to download the soft graph sheet. So you can set all the specifications for your graph sheet, even the size of the paper and the orientation. So after setting everything, you can download it as a PDF file. It's downloaded and you can just download it to your local disk. One such downloaded PDF file is opened in this Foxit reader. Okay, so I prefer Foxit reader over other PDF readers because of its commenting and editing options. So previously already I have kept the calculations ready in my PowerPoint presentation, or even you can use the Word or any editing software where you can key in the expressions, mathematical expressions. Please note the transfer function we have chosen for our illustration is g of s is equal to 10s square. The theoretical background you can get from lecture 4 of frequency domain analysis, that is Bode plot part 1. I'm just going to copy it and paste in the PDF. So Control C and Control V. Yes, you can paste it here. So I'm pasting it as a ready reference. I'm keeping it at the top corner. And now I'm going to change the opacity of this part. Go to properties. After right clicking, you can vary the setting. You can vary the value so that you can see the so that you can make the part more transparent, and you can see the background also a little bit. If you want to adjust, you can still adjust. So the calculations are ready with us. Now we are ready to use the graph sheet. First thing I need to do is the labeling of the axis. For typing any text, you can use the typewriter tool in the command menu. So x-axis is omega. I'm just using W, lowercase w for omega. And just to show the increasing, otherwise the direction of the increasing values of omega, I'm just using the arrow mark. The arrow mark properties can be changed by going to the command format menu. I'm just making it as the line width as 1. Okay, so in the same way the ordinate also has to be labeled. So just before that, I think that it will be good if I divide the graph sheet as two parts, for one for magnitude plot and the other for phase plot. Okay, so this red line is a temporary division. Maybe we can delete it later. So the y-axis labels have to be given. The upper part is devoted for the magnitude in decibels. Okay, so that is labeled, and similarly I can make use of the same text and the arrow direction by Control C and Control V, that is copy paste, and I can edit it here. This is in angle in degrees. So the axes are labeled. Now it's time to label the x-axis ticks. So let us start from 0.01. 0.01, 10 times 0.01 is 0.1, and 1, 10 times is 10, 100, 1000, and 10,000. Okay, so that's done. Now I have to label the magnitude in decibels. So you have to be a bit careful. So from this calculations, I understand that for omega is equal to 1, it is 20 decibels, and the slope is increasing because it is a 0. Okay, so therefore 40 decibel plus 40 decibels per decade. So if we start at the top, if I make the 0 decibels at the top, there will be an issue. So it is always good to start the 0 decibels, at some point lower, because otherwise I'll not be able to plot the magnitude plot for the entire range of frequency. So I take the almost at the lowest point I start the 0 decibels. So all the markings are made, and now it is time to mark the mark for the phase plot. Phase plot is a straight line at 180 degree. So I'll just take the middle of the portion allotted for the phase plot as 180 degree, and each division I take it as 10 degree, and therefore I mark it for every 20 degrees. So these are the markings for the angle in degrees. Oh, it's done. Yeah, the preliminary work is done. So now it is time to plot the magnitude plot. It is at 1, it is 20 decibels. 1 radians per second is 20 decibels. To mark a point, I'm going to use the character x. Okay, so at 1 degree, at 1 radians per second, the decibels is 20, 0, 20, 40. So that is the 20 value. So for 1, it is 20 decibels. So let me mark it as x. Maybe you can zoom it and place it correctly. Okay, so let us increase the size a little bit. Now you can zoom it and verify whether it's ensured that it's at 1 radians per second. Yes, increase, sorry, move it above, move it a little. Yeah, it's exactly at the point. Yeah, so one point is located. And how do you locate the next point? So it is 40 decibels per decade plus 40 decibels per decade. So it is, the point will be above this point, move by 1 decade in the frequency axis, move by 1 decade, and then it is 40 decibels upward. 20, 40, yeah, so that is the point, 20, 40. Okay, so one division is 20 we have taken, so it's 40 decibels. So again, mark the point there, zoom it. Please note we are drawing the Bode plot for the transfer function g of s is equal to 10 s square. Yeah, the point is marked. Now it's matter of drawing a straight line connecting these 2 points. Okay, so let us connect these 2 points with a line. Yes. After connecting these 2 points, I can extend it now. Yeah, let me extend the line for other frequencies also, because it is going to be a single straight line for 10s square, because it's a differentiator of order 2. So when you extend the line, you should be bit sure that the slope of the line doesn't change. Slope is 40 decibels per decade. So ensure that the slope doesn't change. That's all about the magnitude plot. Now let us talk about the phase plot. It is a straight line at 180 degree. So no issues. Again, pick up a line tool and just draw a straight line at 180 degree. Yeah, if you want, you can extend a little. That's it. The phase plot and the magnitude plot is ready, so that the partition line can be removed. Otherwise, it will, give unnecessary confusion. Okay, so you can remove. So I got both the magnitude and phase plot. Of course, you can insert some comments or some labels, other labels also. For example, if you want to display the slope of the line as 40 decibels per decade, you can display that with an arrow mark, or if you want to say that that's a magnitude plot and this is the phase plot, you can do it, or any labels you can do. This is how you can make use of the soft graph sheets, semi-log graph sheets, downloaded from this particular website, and complete your exercises. Thank you.